We'll be moving on to the next chapter, which is network theorems. So we will be studying about different network theorems and how an electrical network is made and what are the components inside this network. All these things we will be studying. First move on to the first let us see what is electrical network. In this you can see many components inside the network like diode, resistors, capacitors, inductors, transistors, voltage sources, current sources, etc. So let us just classify these elements in this electrical network. First I will tell about passive circuit elements. That is, it contains inductor, resistor, capacitor, etc. These elements are having two terminals only. So these are called passive circuit elements. Then other elements like active circuit elements, it is just the elements which gives the power to the electrical network. They are voltage source and current source. So electrical network contains elements which are classified into two. They are active elements and passive elements. Passive elements are all the two terminal elements which does not give power to the network, which draws power from the network. And the other active elements means it gives power to the circuit. That is electrical energy source, that is battery, current giving battery. All these voltage sources and current sources are active circuit elements. Now let us see in detail about voltage and current generators or sources. So here in the left hand side we have drawn ideal voltage source. It shows an voltage supply, that is a battery which gives a constant voltage output from this battery, and in the load connected, ZL is the load resistance connected to the voltage supply, and that is across that resistance you will get a constant voltage which is equal to E, which is given from the voltage source. This is called ideal voltage source. But normally when you consider real cases, real voltage source contains an internal impedance itself in itself. So source has an internal impedance in itself. So the voltage across the load resistance will not be exactly equal to the E value, voltage E. It will be little bit less than that. That is, some voltage will be drawn into this internal impedance of the source. So Zin is the internal impedance that will be in series with the voltage source. But when you consider current source, you can see if the current source, if it is ideal case, in the ideal case there will be a constant current coming out of this current source, and that will be passing through the load resistance ZL. But when you consider in real current source, some current will be passing through its internal, some current will be drawn internally of this current source because of the internal resistance of the current source, and you can draw only parallel to the current source. So some current will be passing through this internal resistance of the current source. Here E is not correct, it should be I in the fourth figure. So I is the current source which gives constant current supply, and if in real current source the total current will not be passing through the load resistance, some current will be passing through the internal resistance. So it will be drawn for the internal resistance. So some a little bit less current will be passing through the load resistance. You will get not exactly the correct current from the supply, total current from the supply, but little bit less than that, because some current will be passing through its internal resistance. Okay, so voltage source and current source are constant supply. They are sources of constant supply of constant voltage and constant current. Now let us move on to electrical network. In an electrical network, you will have different components in it, isn't it? So these network contain different branches also, which contains different elements in the network. So here in this is an example of electrical network which has a power source or energy source, which is voltage source E in the left hand side, and you can see point A and point B there. They are the junction or node. We call it as junction or node. They are the point at which different branches meet each other. So they are called nodes or junctions. Now ACB and ADBC. ACB, small a, small c, small b, that is a branch, isn't it? So it is a group of it is any group of series elements, that is it is elements are connected in series in that branch. So branch is a group of series element. You can call it as elements which are connected in series. That is called that connection is called a branch. Okay. ADB is also a branch. AB is also a branch. You can see in AB there is only one component. We don't need to say that some components are connected in series there, because there is only one element there. So that will also that can be also said as a branch. Now what is a loop? Loop means it is a closed path in a network. You can see there ABDA and ACBA, both are loops. Both are closed loops of elements, or closed loop of a branch is called, we call it as closed path of a network is called a loop. Now let us see what is linear and non-linear network. Linear network means it contains linear impedances. That means when you increase the voltage, current increases linearly in that network. That means voltage and current are linearly dependent. Resistance is a constant there. But non-linear network means it has no linear dependence. Voltage and current depends each other non-linearly. It can be exponential dependence, isn't it? So they depend each other non-linearly. Then that network we can call as non-linear network. Now I have said in the beginning that when you have to use when you have an electrical network, if you want to find a voltage or a current at a particular element, through a particular element, for example a resistor or a capacitor, then if you want to find that current or voltage in that particular element, you need lot of calculation if the full network is a complicated network. But if you use some theorems, network theorems, that will be much easier to find a particular current in a particular branch or particular through a particular element. What is the current passing through? If you want to find that, you can use these kind of theorems. They are superposition. First one is superposition theorem. Second one is reciprocity theorem. Third one is Thevenin's theorem. Fourth one is Norton's theorem. Fifth one is maximum power transfer theorem. So first we will study superposition theorem. In superposition theorem, it states that if a linear system is driven by more than one independent power source, so in a network there are different power sources, the total response is the sum of the individual responses provided, or all other sources are replaced by their internal impedance. That means if you want to find a voltage across particular element, then if there in that network if there are different sources, you just remove all the sources except one and remove all other sources with its internal impedance. Find the current through that element. The same way you do for the other sources also. So if you have many sources, you just keep one and remove all others with its internal impedance. Find the current or find the voltage through one element, then you have all the individual responses, isn't it? Now you have found out all the individual responses, and then you add these individual values of current which you have found, then you will get the current passing through that element if all the sources are present there. Okay, you will understand this when you learn the proof. Okay, now let us go to the proof. You will understand it clearly when you study the proof. So here we have a network with two sources. So in superposition theorem, they states that the network has more than two sources. So here we two or more than sources in the network. That's what I said. Okay, here in this network you can see two sources are there, E1 and E2. Okay, now if you have to find the value of voltage E1, you can find it using the current passing through the network. So the current through Z1 is I1 and the current through Z2 is I2, and through Z3 will be I1 plus I2, isn't it? So now by using Kirchhoff's second law, you can write E1 as E1 is equal to I1 into Z1 plus Z3. That loop is completed now. So I1 into Z1 plus Z3 plus I2 will be also passing through Z3, isn't it? So I2 into Z3 will be the value of E1. Now E2, what is E2? E2 will be I2 into Z2 plus Z3. So the second loop is completed, and then I1 into Z3 will be added. So equation 1 and 2, I hope you understand. It is by applying Kirchhoff's second law. So this is the value of voltages E1 and E2. Now by superposition theorem, what you want to do is you remove all these sources except one source. Okay, so we remove the source E2 with its internal impedance. So replace E2 with its internal impedance means internal impedance is 0 there. So you just short circuit there. So second figure is not is without E2. Now let us find E1 there. Now the current will be different, isn't it? So the current through Z1 will be I1 prime and Z2 will be I2 prime. So the current through Z3 is I1 prime plus I2 prime. Now let us write E1. E1 is equal to I1 prime into Z1 plus Z3. That loop is completed, and then plus I2 prime into Z3. I2 will be also passing through Z3. So you have to add that. Now in the second loop, how will you write? 0 is equal to, E2 is 0 there. 0 is equal to I2 prime into Z2 plus Z3 plus I1 prime into Z3. So we got 3 and 4 equation. Equation 3 and 4. Now we do the other way. We keep E2 there and we remove E1 with its internal impedance. Now you can write the equation 0 is equal to, so E1 is 0 there. So 0 is equal to I1 double prime. The current passing through Z1 prime is a different one. It is I1 double prime and Z2 is I2 double prime. So we can write 0 is equal to I1 double prime into Z1 plus Z3 plus I2 double prime into Z3. The same way, E2 is equal to I2 double prime into Z2 plus Z3 plus I1 double prime into Z3. Okay, you got 5 and 6. So now we have 6 equations. What you do is you add 3 and 5 and 4 and 6. So adding 3 and 5, you will get left hand side is equal to E1. And now we compare it with the equation 1. Equation 1 is E1 itself. Left hand side is E1. So adding 3 and 5, you compare it with the equation 1. So E1 is equal to, adding 3 and 4, 3 and 5, you will get E1 in the left hand side. So equation 3 adding equation 3 and 5, you will get E1 is equal to I1 prime into Z1 plus Z3 plus I2 prime Z3 plus I1 double prime into Z1 plus Z3 plus I2 double prime Z3. Okay, now taking Z1 plus Z3 outside from first and third term, then you will get Z1 plus Z3 into I1 prime plus I1 double prime, and taking Z3 out from second and fourth term, you will get Z3 into I2 prime plus I2 double prime. So you get the right hand side there. Now you do the same as for the fourth and sixth equation. Adding 4 and 6th equation, you will get left hand side is equal to E2, and it should be equal to I2 prime into Z2 plus Z3 plus I1 prime into Z3 plus I2 double prime into Z2 plus Z3 plus I1 double prime into Z3. Taking Z2 plus Z3 outside from first and third terms, you will get Z2 plus Z3 into I2 prime plus I2 double prime, and taking Z3 out from second and fourth term, second and fourth term. Taking Z3 from second and fourth term out, Z3 into I1 prime into I1 double prime. Okay, now you have the new equation and you compare it with the equation 1 and 2. So the first equation, left hand side is E1. So let us compare it with the first here the E1 equation. So when you compare, you can see Z1 plus Z3's coefficient is I1 there in equation 1. The coefficient of Z1 plus Z3 is I1, and the coefficient of Z1 plus Z3 in the new equation which is I1 prime plus I1 double prime. So comparing these two equations with the 1 and 2, you will get I1 is equal to I1 prime plus I1 double prime, and I2 is equal to I2 prime plus I2 double prime. Okay, so you will get now the superposition theorem proved. That is, individual responses are I1 prime and I1 double prime, isn't it? And that will be equal to the total response. So the first figure have I1 passing through Z1. The current passing through the component Z1 is I1. But when you remove all other sources, keeping only one source, all other sources are replaced with its internal impedance, then the current passing through Z1 is I1 prime. Likewise, you do the other sources also. So I1 prime and I1 double prime will be the individual responses. So when you add these individual responses, you will get the total response. So the superposition theorem is proved. Now let us go to the example. I will teach you example in the next class.